Welcome back to episode 12, where we're going to focus mainly on while loops. So, generally, implementing any type of a loop, this will be very similar if you want to implement a do while loop as well. We won't get into that, but there's a good challenge for you if you want to test your skills. So, the piece of code we're going to be compiling today is just going to be our main function as always. We're going to have a variable a, that's an integer equal to 0. While a is less than 10, we're going to loop and print off the value of a, and then we're going to add 1 to a and then redo the loop. So this should print everything from 0 to 9. And then we're just going to return a just because we need to return an integer anyway, so might as well. So now that we have our code that we need to, our goal for the episode, we're going to start as always in our token.py file. We'll scroll up to the top, and in our keywords list, we're going to add while equals while. And we're going to scroll down to our keywords dictionaries. We're going to add our normal keyword. While is mapped to our token type .while. And then our alt keywords is going to be, we'll do we for fun. So we is going to equal token type.while. So that will also map to while for our Gen Z safe language. So now that we're done with the token.py, we have nothing to do in our lexer, so we can move on to the next step, which is our ast.py. In our node type enum, we're going to add the while statement node type. So while statement equals while statement. Then we'll scroll down to our statements. The very bottom of this region, I'll paste in the while statement for the sake of time. So this class is pretty similar to all the other statements. We're going to take in a condition. So if I set this here, we're going to take in a condition, which is going to be our a less than or equal to, or less than 10. So that's going to be our condition expression. Then we're going to take in a body, which is our block statement right here. So everything that's in the while loop. We're going to set two variables, condition and body. So if body is none, we'll set it to an empty list. If not, we'll set it to body. So we'll implement our type as well, type function to while statement, and then our debug JSON as well. So we'll save that. That's everything we need to do in AST. So we'll move on to our parser. As always, we'll go up here to our statements. I'm going to create a new line here. So from AST, import while statement. Now we'll go down to parse statement method. So we'll look for that, parse statement. We're going to add while to here. So case token type dot while. We'll return self dot underscore underscore parse while statement. And now, just as you probably guessed, we're going to implement that function now. So in our statement methods, we'll go to the very bottom of that region. Def parse while statement, take in self, and that'll return a while statement node. We'll set two variables, one for condition equals none, and we'll set one for body. It's a block statement, and we'll equal that to none as well. So now when we get to this token, that means we're on the while token. So in our test, I'll get our test.lime file up again here. So right now the parser is at this while token. So we're going to advance to the next one. So now we're at A. So now we're expecting an expression. So we're going to set condition equal to self.parse expression. And the precedence type we'll just set at the lowest value. So now that this parse expression is completed, we're expecting this left brace. So if not, self.expectPeak. And we're expecting a left brace token. If not, we'll return none, so we clearly have an error. If we do have that left brace, that means we are ready to start parsing a block statement. So we'll set body equal to self dot underscore underscore parse block statement. And then we'll return the while statement node. setting condition to condition, and body equal to body. There's just a quick thing that I remembered. We'll go back into our AST. Right here, this makes absolutely no sense. We're saying this is a block statement, yet if it's none, we're setting it to an empty string. So from the code I just wrote, it should never be none. So we're going to get rid of that whole thing and just set it to body. So now that we have that out of the way, the while statement is done in the parser. So we'll move on into our compiler. In our compiler, the first thing we'll do is scroll to the top. We'll make a new line from AST, import while statement. We'll go down to our compile method. At the very bottom of our statements little section, we'll add a case node type dot while statement self dot underscore underscore visit while statement. And we'll pass in that node. And you'd never believe it, but we're going to implement this while statement function. So in our visit statement methods block, we'll scroll to the very bottom right there underneath if statement. Def visit while statement will take in self, also take in a node of type while statement, and this won't return anything. We're going to start off with just kind of breaking out of our node, so condition equals node.condition, body, not a blocking IO error, block statement, node.body. We're going to test the condition, so test, do an underscore because we don't care about the type. We'll call our resolve value. So we're going to resolve the value of this condition to see whether it's true or false. We need to create a block where the has an entry to our while loop if the condition is true. This is where the compiler would jump to run the specific block of code. So our while loop entry is equal to self.builder.append basic block. We'll do an f string. We'll call this block while loop entry underscore self.increment counter in curly braces to add a number to that. So if we have multiple while loops, we'll know, hey, this is the one, because we'll have a unique number each time. If the condition is false, we need a otherwise block, so while loop otherwise. So the program will jump to this block of code if the condition is false. So the same as before, self.builder, append basic block, f string, while loop otherwise underscore, and then we'll set it to our counter value that it is now, since we already called it here to increment it. I will paste in this little bit of commenting just to help it out. We're making a condition branch very similar to how we do in the if statement. We're going to create a self.builder.c branch. So it's a conditional branch. First thing's the condition, so that's our test value. If it's true, we want to branch to the while loop entry block. If it's false, we want to branch to our otherwise block. And then we're going to set our builder's position at the start of the while loop entry block. We are going to compile the body of the while statement. We're going to test the, so this is what's happening in the while loop entry block. So we're going to compile the body. So this is as if it were true. We're compiling the body, it's running the body, and then we're going to test the condition again because the body is over. So test underscore self dot resolve value. We'll resolve that condition again. If it's still true, it will jump right back to the entry. If not, it'll go to otherwise. So we'll add another C branch, condition branch. If that value is true, we're going to the entry block. If it's false, we're leaving the while loop and going otherwise. And then we will position our builder at the while loop otherwise position. So everything that happens after the block. So in our case, return A is what will be ran once this while loop is finished. After that, that should be absolutely everything we need. So we will bring this test.lime up, go down to our terminal with our Python environment activated, and we'll type in python main.py. So the program returned 10. And here we are, we have 0, 1, 2, 3, 4, all the way down to 10. So program returned 10. And it did not print 10 because A was 10 and 10 is not less than 10. So it broke out when it was supposed to and returned it out. So we'll run it again for fun. Really quick. 1 millisecond here. So there it is. There's the while loops, and you can do just about anything you want in these while loops. You can create an infinite loop and break your computer if you'd like. It does not matter. But thank you guys for watching. That was while loops. In our next episode, we're going to be going into adding continue and break keywords to our language and then implementing them so we can break out early of while loops. So if I were to do if 1 equals 1, or if A equals 5 or 4, we can break out. Or if I just really don't like if A equals 2, if I really just don't like the number 2, I can just continue on the loop. We'll do that before we print because I don't want to print 2. That's what we'll be implementing in the next episode, as well as for loops to kind of cap off all of the different types of loops for our language. Thank you for watching, and I will see you in episode 13.